and this is gonna to be the one of the important section for threading on the CNC cycles. Well, if once you had been shared to start a threading cycle on the CNC, what you would supposed to have? Threading cycles is basically required to generate on given blank or on given raw material. Right now, in this case, I hope that to think on this, to consider a case we have this raw material or the blank is available. And on this blank of 20 mm diameter and 30 mm length, we need to generate a thread called matrix 20 into 1.5. The significance of the matrix 20 1.5 is 20 mm measure diameter, which is shown over here as this one, and 1.5 is the pitch between two consecutive thread. A difference is the 1.5. So once I need to produce this specific type of threads on a given blank, what can I do with the help of the CNC machine? I need to first of all I need to calculate the depth of thread. What would be the depth of thread? And for that I need to find out the minor diameter. I can do this exercise with the help of these two equations, number 1 and number 2. I will use this equation, depth of thread is equal to pitch into 0.6143. If I am going to put the value of pitch is equal to 1.5 and 0.614345, okay, 92145. So one value is arrived over here, one value we received. And now we would like to put this value into the second equation. I am going to put this value in the second equation. I will find the minor diameter. Okay, so for the minor diameter, what would be the formula? The formula would be again 20 is the measure diameter, already has been mentioned, minus in bracket depth of thread, it is the 0.92145 into 2, and that would be equal to 18.60. That would be almost equal to 18.16. Okay, so this is the way that how you can find out the minor diameter. Another easy approach is that you can go on to this site. I'm going to share this site and you'll see that how the values can be carried out. Right now in this one, we are threading onto the male part, minor diameter of the male thread. Okay, so first, second, third, fourth, and fifth line. Fifth line, and these are the matrix thread, and 1.5 mm is the pitch, 1, 2, 3, 4, and fifth one. So the value comes as a 18.160. So that would be the minor diameter up to that depth. From the 20 mm I need to go to generate the thread. And that is my target. Okay, that is my target to go. Now important segment comes in a form of the CNC machine. CNC machines having the different controller, different kind of the controller. And on the basis of that controller, they have the different syntaxes. And you need to put the values and the syntaxes and have to run the program with your brain. You need to put that values with the very clever idea. Once you put the value, run onto the soft material or run the simulator and then check it out. And then after you can go for the harder material. So I'm going to show you the Mac 3 controller, Fanuc controller, and the Haas controller. These three controller I'm going to share with you. So three controller, I'm going to share this word page with you as it is going to get display on your screen. Okay. I'm going to share this Mac 3 G76 cycle. I'm going to share this one Fanuc controller G76 threading cycle and the Haas G76 threading cycle with you. This code file I am going to put in my description. I hope that if you wanted to have, you can carry it out. Okay, so let me try to understand this one. G76 XZQP. This is the one line segment only. In the Mac 3 version, in a one line, if you are going to put the values, you will hit the program. I am minimizing this one for the sake of understanding. Simultaneously, I am opening this program as well. You can see this program. This is the program and this is the syntax. G76 cycle syntax has been mentioned over here, and these are the values. X 18.60 minor diameter up to where I need to reach. In Z, I would like to go up to minus 30. Q2 is the number of spring passes. P is the value of thread pitch, and it is the 1.5. Likewise, this J, L, H, I, C, B, and the tool number. All these data has been mentioned and I have already written this program. I'm going to share this program and will load onto our machine. Once I will load this program on our machine, you can see that it will start to generate the thread. Cycle has started. You can see that once a tool has been reached over there and will come into one particular position, say X20, and we start to move on. Now machine has started to generate the threads. So this is the thread generating cycle in a Mach 3 version. Likewise, if you would like to generate the threads into the Fanuc controller or the Haas controller, I'm going to share it with you. I already have run this program for the several times, so I'm not going to fully run it or the fully execute it because it consumes bit time. I'm going to stop it right now. Next program is mentioned over here with the Fanuc controller. Fanuc G76 threading cycle. You are supposed to write two lines in that controller, and those two lines are mentioned as over here. G76 P, this to 0, this to 0, and this to 0 having the different segments, different explanation, number of passes, angle, taper angle, and this is the thread angle. This is the finished cut, this is the rough cut value in a micron, and this is the finished cut value in the micron. X is where up to you need to go. We would have the value of 18.60, that would be the minor diameter. In which length of a Z you need to go, in our case that would be the minus 30. And this is the segment at where you can see the depth into the micron, depth of a thread into the micron 1000, and that value would become 1840 in our case. This is the Q, and this is the pitch again. We would have the pitch of 1.5. I already have written this program. I'm going to show you. And the program is mentioned somewhat like this. You can see these two lines are very important for generating the thread in a Fanuc controller. P02 in two passes I need to generate. No taper threads are there. So the straight thread we are going to generate. 60 is the thread angle, rough value, finished cut value. I can reduce this finished cut value as a 10 as well if you need to have. This 76 minor diameter and the Z length, where up to which length you need to produce the thread. This is the depth into the 1000 micron, Q value, and the pitch value. So this is the one program which can be run on the Fanuc controller. But let, for the sake of the understanding, see that what is happening if we are running that onto the Mach 3 demo version. I did a mistake. I don't want to go for the logic here. I would rather go to load that Fanuc thread cycle. You can see that one error message missing X and is coming. Still, I'm going to run the cycle. It can perform a task. You can see this. Thread cutting cycle will get executed over here. Yeah. Likewise, in the Haas controller, you can also go for that. One of the important things through this video I would like to share with you is that you need to go for the controller. Which machine has the which kind of the controller, you need to check it out. Second thing is that it will have the particular kind of the syntax. It will having the particular kind of the values for producing a particular kind of thread. You need to put the values very carefully into the syntax, and then after you are supposed to run onto the simulator. Once it is completed onto the simulator, you can go for the hard material. I hope that you have enjoyed. Thank you for the patience listening.